Hey everyone, doing something a little bit different today. Since my recording software decides not to work, we're just going to make this a live stream. And then I'm going to cut it down and make it into a video. But, since the NFL is starting today, week 1, Chiefs-Lions, can't wait, we're going to go over some NFL data and some of the new functions that have been introduced into the nflreadr package. So, obviously, to get started, we're going to load in tidyverse. That's a pretty big one. And then nflreadr. So, if you don't have it, I'll show you in a second how to get those packages in there. We're going to load in GT because we're going to mess with some GT stuff. And then gtExtras, as well as ggimage. So if you don't have those packages, so if it says, package not found, just install that packages, insert your package, so nflreadr, gtExtras, ggimage, and then run that line to be able to install those packages. So, nflreadr is partnered with FTN to acquire some new data. And some of that new data is really interesting to look at, and I'll show you how to acquire it here shortly. So we're going to call this FTN, of course, after you load in all your packages. Then we'll just call the nflreadr package, and we'll say load FTN 2022. And so you might get a cache message and things like that. So run it. And we see we have game IDs, season week, play IDs. So this is kind of some of the fun stuff you get. So what hash it was starting on. So between the hash, between the lines, middle. So if it's middle of the field, on the left hash, on the right hash. Quarterback location, so shotgun, under center, in the pistol. How many people in the backfield, not including the quarterback. No huddle. Is there a pre-snap motion? Is there play action, a screen pass, run pass option? Was it a trick play? Was a quarterback out of the pocket? Was that play interception worthy? Was that play a throwaway? Read thrown is like what read did the quarterback make? So like his first read, his second read, and check down are examples. Is the ball that was thrown catchable? Is the ball that was thrown contested? Is a created reception, so that basically is just, a spectacular catch, drop, QB sneak, number of blitzers, number of pass rushers, is it the QB's fault that he got sacked, and then what date you pulled it. So obviously you see that current date. So let's get into it. Let's select a few of the columns. So we'll do FTN, dplyr, select, we'll say nflverse, game ID, FTN, play ID to is QB fault sack. And then we'll rename these columns. So we'll just rename it. Game ID, not up here. Game ID equals nflverse game ID, and then play ID equals nflverse play ID. So what that is doing there is we're just going to rename game ID to play ID to then join with our play-by-play data set. So let's get the NFL play-by-play data set. So again, from the nflreadr package, we'll load in our PBP, run that. But before we run that, we should have ran this. So now we get the play-by-play data and the FTN data. So now let's just join this by calling it PBP. So left join NFL PBP FTN by combine. This is where those renamed columns come in handy. So game ID, play ID, and then since I'm only concerned about the FTN play IDs, we'll say dplyr filter exclamation point is.naftn play ID. So we'll run that, and now the data sets are matched up. So now let's import our rosters and teams. So I'll just call this rost, load rosters from the 2022 season, and we'll select their player ID, their full name, and their headshot URL. So that way when we're creating plots and logos, we can add in the face of the player, as well as for the team side. Say load teams, select. This is a little bit different, so we'll say POS team equals team abbreviation. Basically, we're renaming the possession team to then be able to match with the play-by-play data. And then ESPN logo, team logo, ESPN. So that way we get the rosters and the teams in there. So working with some fun stuff here. So moving forward, let's look at, I'm curious about motion. So who or which teams do well with pre-snap motion? So we're going to create a data set again, and we're going to say dplyr mutate is motion equals, or 1 equals, as integer. I don't know why my thing is jumping. As integer, as logical is motion. So what this is doing is basically in our data set, we can see right here it gives us true false, but this is just converting it to ones and zeros, so that way we can get our motion data. And so we'll add in another piping operator. Again, just jumping in random places. Filter special teams play equals 0, just to make sure, because we want obviously offensive plays. So then we'll group this together. So group by POS team, which is short for possession team. Summarize total plays equals n, and then motion, again it's just jumping, motion equals sum is underscore motion. And then we'll ungroup our data set to then create a percentage, which is just 100 times round motion divided by plays 3. So what this is doing is now we're getting the percentage of all offensive plays. Was there a pre-snap motion? Now we want to join this data together with an overall data set. So here's one way of doing it. Or to get a metric. So like EPA, like expected points added. This time we'll say filter is motion equals true, because we changed this to an integer just so we can add in the number of motions, but this time we just want plays that were motion. And then we can group by our possession team, summarize. This time instead of saying plays, I'll just call it play. And the reason why is, again, we're going to join these two data sets together to then get EPA by motion plays. And EPA, sum, EPA, na.rm equals true, just in case. And then mutate, EPA per play equals EPA. We'll ungroup the data set and select 3 columns, which are the possession team, EPA, and EPA per play. And then lastly, we'll join these two data sets together. So motion, left join, motion, EPA by possession team. And then to get our URLs for plotting logos, we'll left join the same thing by the possession team. So that period there just basically indicates that we want to left join from that data set we just created. So now we're going to run that, and I'll show you what this looks like. So now we have different percentages. So Miami last year, the Dolphins motioned on 65.3% of all of their plays and had an EPA of 29.6 total. And the Chiefs motioned on 48% of the plays and had an EPA of 131.8, which on a per play basis, the Chiefs are number one, and it's not even close. The next highest team is San Francisco and Seattle, about 0.13 area. But wow, you know. So, getting into the ggimage. Now, you can use nflreadr. That's another package in there. However, when I was kind of like testing through this, it seemed like the player logos or the player URLs and their headshots weren't updated, so I wanted to try to keep it as updated as possible. So there's a way you can still do it, so we're just going to do through ggimage. So simply we're going to create a basic plot. So ggplot motion AES, which is just aesthetics, so that way it keeps it throughout, kind of like the piping operator keeps that data set intact throughout the rest of the code. AES keeps the two variables that you select available throughout the code. So EPA per play, Y equals percentage, ggimage, AES image equals ESPN logo, since we want that image of that team. And then geom vline. So this is basically setting like the average of EPA per play and percentage, and I'll show you what I mean here. So like the x-intercept equals the average of the EPA, so the average EPA per play on motion plays, and then the geom h line, which then will want another line to kind of show averages. Y-intercept equals mean, motion, $percentage. So we're just referencing the motion data set and what column, so we're referencing the percentage. We'll just add in a theme classic, just because I like the classic theme. Some labels, so EPA per play. Y label is motion percentage. And then we'll create a title, so GG title, NFL teams, EPA per play by frequency of pre-snap motion. And then our subtitle can just be 2022 season. So when we run that, I realized I forgot a T in GG title. So then we run that, go to plots, give it a second or two to run, and you can kind of see, you know, a plot here that shows each team's EPA per play on motion plays, as well as how frequently did they motion. So this is taking their expected points added on just plays where they had a pre-snap motion, and then taking the motion percentage of all plays that they had. So like obviously the Dolphins motion a lot. The Chiefs and the 49ers also motion a lot, but the 49ers and Chiefs compared to the Dolphins have a greater EPA per play. And like another team that doesn't motion a lot and maybe could do a lot more in the 2023 season are the Seattle Seahawks, as they were also one of the most successful teams, third in the NFL last year in EPA per play, given that they ran a pre-snap motion, but they motioned roughly 25% of the time. So I think that's pretty interesting to look at. So like we can decide, okay, when does motion become useful? Future ideas is like, what about motion and goal-to-go plays? Does that help? Does a pre-snap motion, affect the defense in that way? So you can kind of think of, ideas and ways to do it. So continuing on, let's look at, say, play action. Because play action has been a topic of debate for a while now, and, teams, it was proven that really play action doesn't really do that much in terms of EPA difference from the previous play. So we'll deploy our filter. We'll just call it PA. PvP deploy our filter is play action equals true. Since we want to get the EPA for quarterbacks, we'll say exclamation point is .na passer player ID. And what essentially this is doing is just removing all instances where it's not a pass. And that also includes sacks. So a pass is technically included with sacks, and then we'll say QB drop back equals 1, just to make sure he's dropping back. And then we're going to group by, and this is where we can create another new column name called GSIS ID, which is just their like NFL ID. That's just for us to then be able to join by the roster to then get the player headshots. We'll group by that. Summarize plays equals N. And then our EPA is our sum of our EPA NA.RM equals true. And then we want to ungroup our data set so that way it's just to go by the passer player. So EPA per play equals EPA divided by plays. And then just to remove any outliers or guys who didn't have enough plays, we'll just say plays are at least 25 play action plays for quarterbacks. And then last but not least, we'll join in that data set together from the roster data set to get the GSIS ID. So then we can kind of look at it this way. Who had the most play action? So Justin Herbert with the Chargers, my guy, had the most play action plays in 2022, followed by Kirk Cousins. And then there's a minor drop off, and then we see Jared Goff, Tua Tagovailoa, and Geno Smith. So seems like those teams run a lot of play action in their offense. But now we can look at total EPA, Patrick Mahomes at the top. So that's pretty good. But then EPA per play, even though he didn't have much plays, Bailey Zappi was pretty successful with the New England Patriots last year. In his 28 play action plays, he had an EPA per play of .538. So pretty interesting to look at. You can kind of see, and part of it too could be the type of running back that they had. So like Ramondre Stevenson of the Patriots had a great year. Alvin Kamara's still Alvin Kamara. Derrick Henry with Ryan Tannehill. Obviously Jamal Williams scored a bunch of touchdowns. So having that to your advantage, might help in some way. So let's plot this. So same thing, ggplot, PA, X equals EPA per play, Y equals plays. And then again, going back to the image. So what I'll do here is I actually copy these 4 lines just to save time. And instead of changing the image to headshot URL, and then changing over some of the column names, so PA, EPA per play, PA.plays. Classic theme, our X label is EPA per play, and our Y label is plays, or I should say play action plays, just to be more specific. And then GG title, same thing, QB's EPA per play action, and then I'll add in a little thing that says minimum 25 plays, and our subtitle, again, 2022 season. So we'll run this, give it a second or two. And we'll see what we get. And this might take a little bit longer since we're dealing with player headshots, and there's going to be a little bit more players rather to deal with than 32. Instead of 32 logos, we've got to deal with 49 players. So if it does take a while, feel free to hit the zoom in button. I'm pretty sure you're probably not going to be able to see this on the stream, so apologize in advance for that. But it works, and you can see the players, so like it's really cool there. So like we can kind of see it there. Feel free to zoom in on it and see, but like again, like Bailey Zappi in his limited time was very good with it on play action. Ryan Tannehill was up here, Andy Dalton, Patrick Mahomes, Jared Goff, Justin Herbert, and Kirk Cousins threw a ton, or had a ton of play action plays. And again, it's I don't know if it's part of the team's MO and offense, but it does play a role. So now we're gonna factor in the GT table. If you saw my college football video, you kind of have an idea of what this will look like. But we're going to add a little bit more stuff. So like the gtExtras table comes in really handy for this kind of stuff. And you can kind of see some really cool stuff here. So let's look at, I'm actually interested to look at how do quarterbacks handle third down pressure? And so what I'll consider is pressure is if there are 5 or more pass rushers on the play. So let's create our data set. So pressure, PVP, dplyr, filter, and pass rushers is at least 5. So what we're doing here is getting at least 5 pass rushers. Same thing. You just want to remove the is.na passer player ID. Add a comma there. QB dropbacks equals 1. And the down equals 3. So third down. And we'll group by our, again, create that new column, GSISID equals passer player ID, just to save a little bit of time. Summarize, plays equals N, EPA equals the sum of the EPA, just remove any random instances. And then if you want to look at sacks, you can look at sacks by just taking the sum of sacks. So you'll see who took a lot of sacks. And then ungroup, mutate, EPA per play equals EPA divided by plays. And let's filter it and say, let's say you had to have at least 5 or more third down plays. So 5 or more third down plays, left join our roster by the GSISID. And so you can see 59 quarterbacks had 5 of those plays. And Matt Ryan was sacked the most. So like we can add another column within this and say, sack rate equals 100 times round sacks divided by plays 3. So which quarterback got sacked the most on third down pressure plays? And it seems like Anthony Brown did, even though he only had 6 plays. Desmond Ridder, but Matt Ryan is up there. Baker Mayfield is also up there. So, and we can fix this later, but in terms of like having multiple, so that just basically means they played for multiple teams. Obviously, like Baker Mayfield was with the Rams and the Panthers last year. Josh Dobbs spent time with a couple teams as well. So we can get rid of that and say, like, hey, you know, we just want a distinct value because they're all the same. But we can see, like, some of these guys, like Justin Herbert, really good on third down when he's getting pressured. So he has had 45 plays. I mean, this is my guy. Justin Herbert, 45 plays last year with third down pressure. And he only was sacked twice. That's pretty good. Trevor Lawrence also in that same boat. Mahomes and Kirk Cousins in that same boat. If you watch quarterback, I haven't seen all of it, but so far I've watched half of it. It's great. It's fantastic. I absolutely enjoy it. I can't wait to watch more of it. But, okay. So there's our pressure. And now we're going to add in from last time. So basically what we're going to do is create a data frame, or not really a data frame, but basically create a set where we can put the player name and their headshot next to them. So what we're going to do here is going to go pressure, select name equals full name, and then headshot URL. We're going to deframe that. So basically what this is doing is taking it out of the data frame and basically putting in one vector the player name and their headshot. So that way when we plot this or put this in the table, we can see the player's headshot next to their name. So we'll run that. Now we'll create a GT table. So GT is really cool. I like it a lot. So let's first select our team, which is our ESPN logo name, because then we can plot that. Name equals full name to get them match with the logo, with the logos set, and then EPA per play. And we'll arrange by the highest EPA per play. Not select, slice. Take the top 5 in EPA per play on pressure, and then GT. And so I'll show you like what a basic example of this looks like. And so what I missed here is actually I need to left join the teams by POS team. And so I need to add in that as well. And so we can kind of see teams EPA per play on this season. So I'll create another filter, and we'll say 10 plays. So that way you can get rid of some of those. So here we go. ESPN logo name. So now we're running across that issue. So what I meant to say ESPN, just ESPN logo. EPA play not found. Now we're just struggling here. So EPA play is right here. Oh, right here I said ERA. Okay, so we run that. And yeah, it'll look a little funky, but we can add more into it. So this, in a basic sense, looks like that. Doesn't look like much, but we can make it really pretty here really fast. So first, let's add in the player headshot. So what we do here is like basically create like a text transform. And we'll say locations equals cells body, because we want to refer to the body of the GT data set, or I should say the GT table. And we want the name, so we want the column name, because then we'll put that logo next to it. So then add a comma. Here, fn is just short for function, and we're going to create a custom function. So function x, and then add in parentheses, or I guess the bracket, because again, to create a function you need one of those brackets. And we'll say GT HTML paste web image URL equals logos x, and then comma height equals 50, and outside of the web image comma x. Because basically what we're doing is we're looping through those logos. And, oh, excuse me, I completely forgot another one. So on top of it, we'll add an lapply function x, because this is where we're going to do a list function, which then allows us to create those data sets. So let me make sure we're in the right spot here. So that's the lapply. Perfect. So basically what this code is doing is it's transforming that player text name into player text name with their headshot. And then another way to do it in an easy way with the gtExtra package is to do it gtImage rows, and we'll say columns equals team, and image source equals web, and our height will also be 50. So we'll run this, and now it's looking a little bit better, right? It's looking a little bit better, a little bit cooler. So you can have the team, the line, and I mean, like, it's really cool to see the matchup we're gonna see tonight. Were the two highest players amongst third down plays with pressure rates in terms of EPA per play, and Jared Goff and Patrick Mahomes. So they can handle it on third down with pressure. They were the two best, minimum 10 plays last year. So now let's add in, let's make this kind of sporty. So again, gtExtras has some really cool features. One of them is adding in a theme. So we're going to add in an ESPN theme. And then we're going to add in a few other things. So like we're going to format this number. So our columns equals combine EPA play. I do that just in case if you want to combine more columns or add more columns. And we want to set it to 2 decimals. Let's add in a little color. So we'll say data color, columns, same thing, combine EPA play. And we'll say colors equals greens. Let's just make it, the more green it is, the better. And then we'll add in some labels. So we'll say EPA play. So what I'm doing is basically just making it more professional looking by changing the column's name. So EPA play, team, just with a capital T for team, and then name, same thing, name, plays. So we get our column labels. And then I'm going to add in a different table font. Again, this is, you don't have to do this, but this is to show you if you want to add in like certain fonts. So we'll say font equals list, and what list do we want to pull from? Google Fonts. What Google font do we want to pull from? Roboto condensed. So you can go on googlefonts.com to see what kind of Google fonts are available and what you like, and then run it from there. And then we'll add in one last thing, which is default fonts, just to indicate, hey, here's the overall set that we're pulling from. And we'll add in a tab header, and we'll say title equals QB's EPA per play on third down facing 5+ rushers. And then we can add in that subtitle, 2022 season, min 10 plays. And then last but not least, let's add some table lines. So op table lines, just to make it more professional. And then add in a footnote, just so you can get your work shown. Footnote equals data nflreadr, and that is my Twitter, so feel free to follow. So now we'll run all of this. It says well, sometimes you gotta spell footnote correctly. So now we run this, and look how much better it looks. So QB's EPA per play on third down facing 5+ rushers, 2022 season, min 10 plays. And we can see the two top guys are playing tonight, so I can't wait. Oh, so when we see pressure, these are the most successful guys with a positive EPA per play. Can't wait. I'm so excited, but thank you so much for watching. I really hope you enjoyed this. Super excited for the NFL season, and I can't wait. So I am just beyond excited for football season, and who would have thought that we got the two quarterbacks that were the best in third down blitz plays last year playing tonight. So can't wait. Thank you so much for watching.